Okay guys, quick video on conditional probability. Again, this is something that you're probably already aware of, so it shouldn't be too bad of a video. So, conditional probability. The probability that we assign to an event can change if we know that some event has already occurred. So the probability that one event happens given that the other or another event is already known to have happened is called a conditional probability. So suppose we know that event A has already happened, then the probability that event B happens given that A has happened is denoted by the probability of B given that A happened, or the probability of B under the condition that A happens. So generally your total outcomes here will be significantly different. Okay, so to find the conditional probability of an event A occurring after event B has already occurred can be used as the probability of A and B over the probability that B happened. Okay, and then it would just switch roles. So if you're looking for the probability of B given that A already occurred, it's still the probability of A and B, but this time it's over the probability of A. Okay, so a quick few examples. So these examples are fairly easy for us to do, and I'm not going to be using the formula a whole lot because we have a two-way table here, so there's kind of no need to use the formula because we already have the breakdowns. But I think this example kind of shows the progression of the different probabilities that we've seen. So let's take a look at this, and then we'll do a check your understanding. So, first one, what is the probability that the driver is a student? So if the driver, 359 drivers, 195 rather, are students. So 195 over 359. And then, of course, you can express this simplified if can be, or a decimal, or a percent, doesn't matter. I'm going to leave it though. So part B says, what is the probability that the student, that the driver rather, drives a German car? So if we're looking at the driver driving a German car, we're going to be looking at the 45 German cars over the 359 drivers. So 45 over 359 and done. Okay, next up, let's throw that away. Okay, so what is the probability that the driver drives an American or Japanese car? So we're looking at our or probabilities here. So I'm going to be looking at the 212 American cars plus the 102 Japanese cars, which is going to be 314 over the 359 cars. But of course, you could have done that as a complement because there's only three options. So you actually could have done 359 minus the 45, which would have given you your 314 there as well. Okay, and now what is the probability that the driver is staff or drives a Japanese car? So this one's going to have an overlap. So this one here, this was disjoint or mutually exclusive. This one is non-mutually exclusive. This is not disjoint. Okay, and when it's not disjoint, you will have an overlap or a double count, and so you have to subtract that out. You have to take that out of your probabilities. So we're going to have let's say we have staff that drives a Japanese car. So we have the 164 staff plus the 102 Japanese cars, minus the 47 staff that drive a Japanese car, And so, because that's your overlap right there. And so that would give me, 219 over the 359. Okay. Okay, and now last examples. Gotta clear that out. Okay, and so now we're going to get into our conditional probabilities. So, if the driver is a student, so here's your condition, what is the probability that they drive an American car? So, if the driver is a student would mean that we're going to just really be looking at these numbers here. So if the driver is a student, what's the probability that they will drive an American car? So these are the two we're concerned with. And there's your probability, your conditional probability. So you're not looking at the 359 anymore because you're just focused on if they are a student. So similar to that would be the next one. Let me switch colors. Okay. So what is the probability that the driver is a student if, here's your condition, if the driver drives a German car? So if that's the condition there, then the only thing I really want to look at for this one would be this row right here. So if the driver drives a German car, here's your condition right here. So your total is going to be the 45, not the 195, not the 359. So, and we're looking at students, so 33 out of the 45 German cars are driven by students. And that's it. So let's do a check your understanding. Let me get rid of that page or the work. And a check your understanding. So I'm going to give you guys a few minutes to do it, and then I think I'll put up the answer because it's a pretty quick one, and so we could save some time in class. So read it over. You may want to pause it, find your answer, and then play it to find or to check your answer with mine. Okay, so we're looking for the probability that a randomly selected resident who reads USA Today also reads the New York Times. So we're looking for New York Times given that they read USA. So we would be looking for, so if B is the event to represent New York Times and A is the event to represent reads USA Today, I'm actually looking for the probability of B given that A already happened. So given that A already happened would be this circle here. So it's the everybody that reads USA Today, which would be 0.40. Add these two together, okay? And the probability that they also read New York Times, given that they read that, that's that overlap there. So that's that 0.05. I guess we could do this one and plug it into your calculator real quick, and 0.125. And that's it.